Let's go over a practice problem for this week's discussion quiz. Question 1 says, let f of x equal x to the fifth plus 2x squared minus x minus 4. I want to use an appropriate theorem to show why f of x must equal 0 on the interval from 1 to 2. So I want to state the theorem that we use and explain why we are allowed to use it. For this problem, I'm going to use the intermediate value theorem. This theorem says that if you have a continuous function on a closed interval, then it will assume every value between the function evaluated at the two endpoints. So what I'll do is I'm going to check to make sure that f is continuous on the interval from 1 to 2. I'm going to see what the endpoints equal in this function and see if the number 0 is between them. So to start with, we have to check, is f continuous on the interval from 1 to 2? Is this true? And the answer is yes. And the reason is f is a polynomial, and polynomials are continuous everywhere. So I'll say f is a polynomial, and so continuous. On the interval from 1 to 2. Okay, so that's good. Next, is the number 0 in between f of 1 and f of 2? So next step is I want to compute f of 1. F of 1 is equal to 1 to the fifth plus 2 times 1 squared minus 1 minus 4. And if we simplify that, that's 1 plus 2 minus 1 is 1 minus 4 is negative 2. Next, I'll check f of 2. Okay, so that's 2 to the fifth plus 2 times 2 squared minus 2 minus 4. So 32 plus 16 minus 2 minus 4. Okay, that's 34. And here's what we have. We have a continuous function. At f of 1, it's negative 2. At f of 2, it's positive 34. At some point, it must have passed through the number 0. So I'm going to note that f of 1 is less than 0 is less than f of 2. That is, 0 is definitely between a negative and a positive number, negative 2 and positive 34. By the intermediate value theorem, we can say, so I'll say by the intermediate value theorem, there is a number c in the interval, the open interval from 1 to 2, such that f evaluated at this number c is equal to 0. And that means there actually is a solution to this equation. It's this number c whose existence is guaranteed by this theorem. So the answer to this problem is, yeah, there is a solution. I don't know what it is. This theorem doesn't actually tell you what the number is, but it does tell you that one must exist.